Hello everyone, welcome back to my channel. It's me Abhay. So today we are going to start a new series that is vectors. Okay, so let us start the first part of it without wasting any time. Okay, so what and all are there in the first part? Let us see. In first part, okay, I will be covering what is magnitude and what is direction. We learn something called as scalar quantity. We learn about something called as vector quantity. We'll also learn about something called as vector scalar combination in this part 1. Okay, first of all, let us learn about something called as magnitude and direction. Okay, what is magnitude and what is direction? Let us see. Assume you have a car. Okay. Now, let us say the car is moving with a speed of 5 meter per second. Okay. Towards right. What is magnitude? This value, which I told, na, numerical value, 5 meter per second. This is called magnitude. Okay. And this direction which I am specifying, is it moving right? Is it moving left? Is it moving 45 degrees from x-axis? Is it moving 45 degrees from y-axis? 60 degrees from x-axis? The direction which you are specifying is, this is direction. Okay, I think this should be clear. Let me give you another example. Okay, assume you have an aeroplane and this aeroplane is moving towards south. Okay, and its speed is 100 kilometer per hour. What is magnitude? This is magnitude, and this south is what? Direction. Clear? That's it about magnitude and direction. Let us go to the next part. First, we learn about something called as scalar quantity. What is scalar quantity? Let us see. It is a quantity which is independent of direction, or a quantity which has only magnitude and no direction. This is called as scalar quantity. How? Let us see an example. Distance, you have temperature, you have mass, you have density. Okay. What is scalar quantity? It's like I will tell only the magnitude, but it has no specific direction. Okay. You need not tell any direction. Okay. That is called scalar quantity. Now, the question comes is, how do we check that? Okay. If I explain this, I think you will be clear of what is scalar quantity also. Okay. Let us see. Now, first of all, let us take an example of a scalar quantity, which is mass. Assume this white box is weighing machine. Okay. Now, here it gives reading what W, let us say. Now, if you stand towards the side, same man, okay, if you stand towards the side, will the reading change? Still what reading will be W. Now, if you stand upside down on the weighing scale, still weight is changed. No, 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 no. It is what? Same. So, however you stand, what is it? Your weight is same. So, do you need to specify the direction here? No, you should just tell what? His weight is W kg. That's all. Okay? Should you tell his weight is W kg when standing right? His weight is W dash kg when standing left? No, it's always same. Whatever direction he stands, it is always same. So only what you have to specify magnitude. Direction not required. Okay. Let us talk about another example. Let us talk about another example. Temperature. Okay. Assume we are in a box whose temperature is T. Now, assume this red color arrow mark is what? Thermometer. Now, if you measure over here, assume this box has uniform temperatures distributed uniformly. Now, if you measure the temperature in this direction, or from this direction, or from this direction, temperature is always same. Reading is constant. Reading is same. Correct? However you measure, if you want, you can measure it like this, measure it like this, okay, measure it like this. Anyways, if you measure, the reading is same. So does it depend upon direction? No. What does it depend upon? Only magnitude. So what you will tell? The temperature of the box is T degrees Celsius, or T degree Fahrenheit, or T Kelvin. Correct? Will you say it is T degree Celsius when you measure it upright, T dash degree Celsius when you measure it like this direction? No, it's always same. So only what do you specify only? You only specify the magnitude. Clear? Now, one more example, which is density. Now, if you take a given liquid, okay, its density is always constant, no? It doesn't matter how much liquid you take. It doesn't matter if you tilt the liquid by 45 degrees, 30 degrees, 32 degrees, 36 degrees. It doesn't matter. Okay, its density is always constant. So does it depend upon the direction? No. What does it have? Only magnitude. Will tell its density is rho. Its density is 5 kg per meter cube. Its density is 10 kg per meter cube. Like this you tell. Correct. That's it. What is a vector quantity? Let us see. A quantity which depends upon the direction is called vector quantity, or what you can tell which has both magnitude and direction is called vector. What was scalar? Scalar had magnitude only. It has only magnitude. Okay. What does vector have? Vector has both magnitude and direction. Here, direction is important. Magnitude. Vector has both magnitude and direction. You have to specify. If you only specify the magnitude, it's incomplete. You have to specify even what? The direction. Okay. Here are some examples. Force, acceleration, displacement, and velocity. Okay. We'll see some examples. I'll explain examples in detail. Now, how do we know which is a vector? That is a common question. We'll see. Okay. Now, assume you have a box. Okay. Now, assume you have this box. What do? You apply force from this, you apply force in this direction. How does the box move? It moves upwards. Now, when you apply the force this side, the box moves this way. When you apply the force in this direction, it moves what? Diagonally, like this. So, what does it mean? It depends upon the direction, correct? You have to tell, I am applying 5 Newton of force in north to south direction or 45 degrees with respect to x-axis. Like this, you have to specify the direction, no? Because see, is it same? If you apply the force in this direction and this direction, it's not same. It's not having the same effect. This is moving up and this is moving side, which is not same. So it depends upon both what? Magnitude and direction. Why does it depend upon magnitude? Let us say you apply 5 Newton force, it will move this direction. If you apply 10 Newton force, it will move even further. If you apply 20 Newton force, it will move even further. If you apply 2 Newton force, it will move less forward. So it depends upon the what both magnitude and direction. Clear? Second example, velocity and acceleration. Okay. Now assume you have an aeroplane which is flying. There is a big mountain and assume this is the landing base. Landing base. Okay. Assume this is landing base. So you are the commander. Okay. What you have to do? You have to command this plane to land it over here. Now, what will you tell? This is moving at some speed. If it keeps on moving straight, don't you think it will crash to this mountain? So what you will tell? You will tell the helicopter or tell the pilot. Sorry, you will tell the pilot to do what? You will tell the pilot to move 500 meters above. What are you telling? Move 500 meters above. Okay. You're telling move 500 meters above with a speed of let us say 100 kilometer per hour. Will tell move 500 meters above with 100 kilometer per hour. How you are moving? With what speed you are moving? 100 kilometer per hour. Where are you moving? Above. This is magnitude and this is direction. Okay. So velocity has what? Both magnitude and direction. So don't you think it's a vector? Okay. Now aeroplane is here. Now what do you need to do? You need to slow it down a little bit. Okay. And it has to move forward. Now what you will tell? You will tell the pilot to reduce the speed to 10 kilometer per hour. Okay. And keep on moving forward. So you are decreasing the speed. Okay. Rate of change of velocity is nothing but what? Acceleration. Okay. Rate of change of velocity is acceleration. And what are you telling? Keep moving forward, but decrease the velocity. Keep moving forward, decrease the velocity to 10 kilometer per hour. Okay. Now, let us, what is the acceleration? 100 minus 10 by, let us say in time t. Okay. Now, assume a deceleration is some a. Okay. Now, this will have some magnitude and you're telling keep moving forward. Okay. Keep moving forward with deceleration of a meter per second square. Now, what does it mean? You need both magnitude and direction. So acceleration is also what? Vector. Okay. Now, airplane is what? Over here now. Now what you need to know? You need to move downwards. So what will tell? Decrease the speed and come downwards. So you're telling decrease the speed to 50 kilometer. Now increase the speed. No? Now increase the speed to 50 kilometer per hour and come down. Correct? What is it? Magnitude, direction. Okay. Now you came here. Now you tell move forward and decrease the speed further to 2 kilometer per hour. Again, forward 2 kilometer per hour. What does it have? Both magnitude as well as direction. Clear? Done. So I think you understood why velocity and acceleration are vectors. Let us go to the next part. Vector scalar combination. What is this? Assume you have two vectors. You have a vector quantity and a vector quantity. If you add those two vectors, do you get a vector or a scalar? You don't know. Scalar plus scalar, do you get a scalar or a vector? How do you identify? That we learn in this topic. Vector into vector, scalar into vector, scalar into scalar. What do you get? Vector or scalar? All those things also we learn. Okay. First, we learn about the addition part. Listen to me. When you add two scalars, you get a scalar. When you add two vectors, what do you get? A vector. But when you add a scalar and a vector, it is not defined. Okay? This is not defined. Scalar and a vector, you can't add. Okay? Not possible to add. You can't add scalar and a vector. So you can directly tell can't add. Okay? Scalar plus scalar, what are you getting? You'll get a scalar. Vector plus vector, you'll get a vector. Scalar plus a vector, not defined. Assume you have some mass 10 kg. Okay. And you're adding another 10 kg. What is the total weight now? 20 kg. Now, this is what? Weight. Weight is what? Scalar. Okay. One more thing. Assume you have a helicopter aeroplane moving at 10 meter per second in this direction. Now, what you are telling? You give an order to increase 10 more meter per second in the same direction. Now, what is its final velocity? 20 meter per second in this direction only. This is what? Vector. So, vector plus vector is what? Vector only. Okay. Can you add weight and velocity? You can't add, no? You can't add. So, it is what? Not defined. Clear? Next. Multiplication. Very, very, very important. Whenever you multiply scalar and scalar, what do you get? You always get a scalar. When you multiply scalar into vector or vector into scalar, you always get a vector. Now, what happens if you multiply two vectors? This is quite interesting and this is will be dealt in a separate topic, okay, called as vector multiplication. Okay, there is something called as vector multiplication, which is a huge topic. Okay, this I will be dealing it in the later parts of vector. Okay. Now, as of now, we'll learn about these three only. Scalar and scalar, if you multiply scalar, that's not a problem. Vector and scalar, you are getting vector. Okay. Sometimes you may get confused. Here is what I do to remember. take any scalar quantity. Okay, take any scalar quantity. I will take a number. Okay, 2. A number is a scalar. Does it have direction? No. I can take a number as scalar. Okay, I will multiply it with 10 meter per second. I'm doubling the velocity. What is it becoming? 20 meter per second. It is still what? Vector. This is what? Scalar. This was scalar. This was vector. What am I getting? Vector. Okay, you can remember it like this. Clear? Done. Next, we'll deal some questions now. Pause the video and tell if time is a vector and if momentum is a vector or a scalar. Tell me quickly. Okay. Now, let us see the answer. Time. Time is what? Of course, it's scalar. Now, whenever someone asks you time, what is it? You'll tell 8 o'clock p.m., 8 a.m. You'll tell 9 p.m. Okay. 12:30 a.m. 12:30 p.m., 7:30 p.m. Like that you will tell, no? You'll tell 12:30 p.m. from right direction, 12:30 a.m. from left direction. Okay, you'll tell like that. No, no, no. What you will tell? It is 12:30. That's all. What does it have? Only magnitude. It will 12:30. It has only magnitude. So time is what? Scalar. Okay. What about momentum? Momentum is nothing but vector. Okay. How is it vector? Let us see. Okay, we'll prove this now. Listen to this proof very, very carefully. Okay, it will be helpful. Now, by 9 standard formulas, you should know that momentum is nothing but mass into velocity. Okay, momentum, which is represented as P, is nothing but mass into velocity. Okay, this arrow symbol represents this is what? Vector. No, mass is what? Mass is a scalar. Velocity is what? Velocity is a vector. So this arrow mark I have put. Now, whenever you multiply a scalar and a vector, what do you get? Vector. This is what? Scalar. This is vector. When you multiply these two, you are getting vector. So hence what? Momentum is vector. Okay, this is how you prove. Whenever you have a confusion whether a quantity is vector or scalar, you write its basic formulas, identify scalar part, vector part. Okay, then you find out whether scalar is it, it's a vector scalar, vector. Okay, then you identify this quantity as vector or scalar. Clear? That's it. One more question. Prove that force is a vector quantity mathematically. Same like what we did for momentum. Take this formula if you don't know. Force is equal to mass into acceleration. Mass is what? Mass is a scalar quantity. Acceleration is what? Vector quantity. Now, vector into scalar nothing gives what? Vector. So force is nothing but a vector quantity. That's it. See, it's so simple. Now, try this question on your own. Prove that displacement is a vector mathematically. Okay. In case you don't know the formula, displacement, which is represented as s, is nothing but velocity into time. Okay. This you can do it on your own. Okay. Try this on your own. It should be easy. This is what homework. So that's it about this vectors part 1. Okay. So next is what vectors part 2. Okay. So see you in that video very, very soon. Until then, see you. Bye bye.